All right, so our next speakers will be covering what's coming next with improvements to the HPCC platform, looking at the version 5.0 and 6.0. Welcome to the stage Senior Architect Gavin Halliday and Technology VP Richard Chapman.
You're simply the best, better than all the rest, better than anyone I've ever met. I'm stuck on your heart.
Okay, thank you. Looking at Zach's graph, I know he was quite pleased by how high it was, but I was a bit concerned by the way it went straight down like this. So hopefully you won't fall asleep, but do that. Have I got the slides? Right, what we're going to do now is we're going to spend quite a lot of time on looking at a kind of overview of what areas we're going to be looking at, where we've done work and where we're going to be doing work in the future. And then I'm going to do that, and then we'll switch over to Richard later, and he'll tell you when you're actually going to get that stuff. Okay? We actually had an off-site of Richard's team about a month ago, and this was one of the things we were discussing. What are we going to do next? Part of it was definitely motivated by the fact that we got to come up with something to go on these slides, so that focused our minds a bit. But also, we have got far more ideas, both from within the company and outside, of things we can do than we can possibly do. So we needed to kind of think, what should we be focusing our effort on? I don't know that we came up with a complete list of the actual items we should be working on, but we did come out with a bit more idea of the main strategic areas we should be focusing on, and that will kind of help us to know which items fit in with that focus and which we'll just have to put off or leave for later. Most of these are probably fairly self-explanatory. I don't like operational self-sufficiency because it's got the acronym OSS, and OSS for OSS could get very confusing. The idea, I think a better idea is exceptional laziness, really. We don't want to be contacted about problems with the platform, so we want it to work perfectly. We want you to know how to use it immediately. And the same goes for operations. As the platforms use more and more outside risk in Reed Elsevier and other places, our risk operations guys don't want to be contacted saying, oh, we tried setting up this system on AWS and we couldn't get it to work, can you help us? So I think a large part of our focus, or one of our areas, is just making sure that people who are using the system, it works, they can understand how it works, and when things go wrong, they can sort them out themselves rather than having to escalate it up the chain. So I've kind of split it into three areas. The first one is resolving problems. Now, I don't know, anyone who was at the table when Luke said error messages from the compiler, they're no problem at all. You should have seen me go, yes! But I'm not sure that most of the people in the room would agree with that. There are definitely occasions where the compiler will give you some completely obscure error and you have no idea what's causing the problems. So that's one area we want to focus on, is making those errors clearer about what's going on. And also, I mean, he showed that error which was perfectly clear from Thor about the problem with the if activity number 15 in that graph, but we can do work to clean that up so that actually, rather than using abbreviations, tells you, go and look at activity 15 in your graph, you're calling this function. It should also be able to tell you it was on slave number 5, and I don't know, maybe it gives you a link to go and look at the logs for that thing. So just making the whole experience of trying to work out what those errors actually mean a lot better. We already have some statistics, so for things like skew in your graph, we want to add more statistics to make it easier for you to understand what's actually happening, where the time's going in your queries, and just so that you think this isn't going right, dive in there and, oh, that doesn't look right. And Gordon's been doing some work, some of you who've used the 5.0 system, on producing a heat map for the graphs, so you can quickly go in and one's flashing red, and you go, oh, that must be where the problem is. So kind of focusing your attention and giving you the information that you need to be able to go and find problems in your code, and find problems in the system, but there aren't any of those. I guess even better than finding out what the problems are is if the system told you beforehand that there were problems happening or what the problems were. So I think, have we got other sections on the Ganglia and Nagios integration? That's going to give you a much better idea of how the whole cluster is performing as your query is going, and if there's a problem in the cluster, it might be easier to see why your query is going. One thing Jake's added recently is quite often, well, not very often, but sometimes there might be a problem with the hardware, but you as an ECL user won't have any clue that that's happening. You just know that your job's going slow for some reason. He's now added some work, done some work so that any errors about disk faults and things like that actually get fed back into the work unit. So if you as a user thinking this job's going slow, you go and look at the work unit and it says disk failure on drive 3 or slave 3, you know, okay, I need to go and contact operations, and hopefully that will just avoid Jake having to go and investigate quite a lot of the issues and get your jobs running more quickly. Warning improvements. It's interesting, quite often when we get to delve into problems with queries, you say, this isn't working, or this is going slowly. If you go and look through the warnings, there is often something saying, by the way, this is going to go very slowly, are you sure you want to do it? Or words to that effect. But quite often, that's hidden within 100 other warnings that are being ignored. So one thing we wanted to do is to encourage people to have the philosophy of having no warnings in your code. So what we've tried to do is to remove warnings that aren't really helpful. We've tried to tighten up some of the warnings, so maybe only give them when we're really sure something's wrong. But the other thing we've done is to, in the compiler, all the warnings are now allocated to different categories. So there are categories for, I should have remembered this because I can't remember them, things like problems with syntax or problems with expressions that you're doing something. And one of them is a category of mistakes where theoretically this could be sensible ECL, but 99% of the time it's pretty stupid ECL. Or a typing error. So one good example that Jamie added recently is where somebody's indexing a string and they've said 1.3 instead of 1.3 or 1.10. They're thinking they're getting a subset of a string, but actually they've used a floating point number, so they only get the first character. And so now that's on the category of you really need to go and look at this. And in the ECL server, you can configure how those different categories are interpreted. So for the mistakes one, I would almost recommend that it's configured so that all mistakes are actually reported as errors. So hopefully things like that can mean that you can go through, clean up your code, get rid of warnings that they should be there, but you know they're there for a reason. And then once you're down to no warnings, then when you get a warning coming up, you can focus on it and go, oh yes, that actually is illustrating a problem. So, what's the ease of use and tackling known issues? One of these is DALI. At the moment, DALI is used for lots of different things. So it's used for locking, it's used for storing file information, it's used for storing work units, and part of it is called SDS, which stands for Small Data Store. Now, there is loads and loads of information now stored in DALI, and it would make a lot of sense for DALI to be used for the things that it's good at, maybe the locking, but some of the big things like work units would actually be much better moved out into another database like Cassandra. It should speed things up. It will probably also mean that you don't need to archive your work units, so you'll be able to see all the history. At the moment, they need to be archived just because DALI would get too big. Other things about making things easier, I mean, John, with his Genesis server, has sorted out how to deploy HPC systems within the company, but outside the company, we need to make sure that it's easy to deploy on AWS or to different platforms. So, there. You've heard about security from a few different areas. I mean, customers are asking for it. We don't want the reputational risk of, we've all heard about people breaking into Home Depot or things like that and getting in with data. We've got to protect our systems. So there are lots of different ways in which we've talked about it. Now, thankfully, the encryption at rest is probably handled in the hardware these days, and some of these things will require changes in the software, others we can do by using hardware. But this is a big issue. I mean, one thing is also moving to the cloud. We've historically thought of a Thor system as kind of an isolated unit that within that it's fine, but once it's running on a cloud, you don't know where those servers are, the communication between them. We don't want that intercepted, so it may well be that on some systems, all the communication between the Thor slaves is also encrypted, just to make sure that nobody can actually get at our data. Yeah, we're always concerned about performance. There are several different reasons why queries go slow. One quite often is that the data is skewed. It's interesting to know that the sort was probably the first activity that was ever implemented about 12 or 13 years ago, and hasn't had an enormous amount of work done to it since. It's basically worked. But since then, we've actually got quite a few ideas of how to improve it, how to improve the way it reduce the skew on the data it produces, things like that. So I like to deny it, but every now and then the code generator does cause the same code to be executed twice. Sometimes it's just a side effect to the way the language is done, but we want to work away at things to stop that happening so that the queries aren't doing things twice. And there are lots of things we can do in Thor to improve the way we use resources. So whether it's using multiple cores better, or just the way we manage multi-threading. Sometimes if we try and do too much in parallel, the cost of having all the different threads doing the processing can be a bit much. So we've got lots of different ideas of how we can improve the performance. And there are lots of capabilities as well. So quite often, like some of these, they're involved in integrating other third-party products, or so we've already heard how embedding Java has helped with the text analysis. Integrating some of these databases will maybe make database type things easier to do. So Anthony's Fishbeck's been doing some work on reading and writing JSON files to make interoperability easier, and then various other capabilities. So the ARM chips are going 64-bit and are gradually moving into the data center. So we want to be able to, there are some workloads where they'll be good. We want to make sure that the platform is ready to cope with that, or GPUs. So we need to keep making sure that we're up to date with the technology. And yeah, these are more things we've been working on. The last thing on that list was salt and kel support. And maybe one question is, why is that special? I mean, in some ways, it's just an example of improving the performance and adding features that they need. But as I think we've seen from the other presentations, more and more of our code and especially the really heavy processes are going to be controlled by salt and kel. One of the advantages of salt and kel is that all the knowledge of David and his team can be encapsulated in the generated code. But that also means that if we, in the platform, can target that code that's generated, then we get a lot more bang for our buck, because we know if we improve this case, it doesn't just improve that query, it improves all the other queries that are generated similarly for salt. So that might be performance improvements or new features. It might be worth covering a couple of examples. So at the offsite and before that, we looked at, I think one was an example from kel, one was an example from salt, and had a look at the code they were generating to see what we could do. So the kel example, I think it was analyzing the fields in the data set to work out what the values were. So we took a look at the code, and yeah, we came up with a few suggestions that we fed back to the team saying, well, if you change the ECL so it's like this, then yeah, it might go quicker. And I think it went 50% quicker or something like that. But then also Jake had a look at Thor and found out, well, quite a lot of the time is going in. This was a roll-up with lots of child query, which was doing lots of work in it. So not something that Thor has done a lot of in the past, but is now being exercised a lot. And he found that quite a lot of the time was going into starting up the child query and then finishing it. So by tuning that, you could actually cut that down quite a lot. And that's going to give benefits to any query that has got child queries. We also incidentally found, for some strange reason, that it was running much quicker on Thor than Roxy. And when we delved into it, we actually found an issue with Roxy that we've now fixed. So, so looking at that example, actually we improved the ECL, we improved the platform, and in fact we improved a platform we weren't even trying to target with that example. Another key bit of salt is in the matching. So we've done several things. Just to give you an example of how it's worked, on the first version, I think David had code that if it's a really big data set, you need to do a normal join, but if it's a small data set, you can do a lookup join. So there was loads of conditional code saying, if the size is about this, then go for a lookup join, otherwise do a full join. So apart from the fact that the graphs looked horrible and we couldn't work out what it was doing, we thought there's got to be a better way of doing it. So that is how the smart join came about, which basically does a lookup join. If it gets too big, does some magic and then does a local lookup join. If it's still too big, then it kind of gives up and falls back to the normal join. Similarly, in Salt, quite often it's doing some very complicated edit distance functions in the matching, and those are fairly processor intensive, so that led Jake to add support for executing those in parallel. When we recently looked at one of the examples, we thought, well, this is going slow because it's actually got skew on the join. It's an example where you say, I want to definitely match this, and then I want to match as many of these as I can until I get down to 5,000. And then once I'm down to 5,000, that's small enough that I can try all of them against everyone else. And with that join, it was coming out skewed. And when we bounced the ideas around a bit, we thought, well, actually, we could do this better, so that at the moment, we kind of just split it up by the bit that definitely must match, and then the other bits are all done locally. And if we build more intelligence in and kind of do that incremental splitting up before we do the partitioning, we can actually get much better skews coming out of it. Now, the problem with that is it probably requires that we rewrite the sort code, which no one's touched for 10 years, so maybe we'll give it to Jamie as a new project. So, but that's kind of, so I think that's going to be happening more and more, that a lot of what we'll be doing is working with David and the other teams to take a look at the things they're generating and making sure that our platform really supports them well. Okay, so that's a bit of an outline of what our areas are. So making it easy to use, performance, and I've forgotten the other three. But so over to Richard, who's hopefully going to tell us when we're actually going to get these features.
Okay, I'll fairly quickly go through, an approximate roadmap of what's going to be in, or what is in 5.0, what's going to be in 5.2, and what's going to be in 6.0, bearing in mind some of the priorities that Gavin told you about earlier. So 5.0 was released in July. We'd like to think that anything earlier than 4.0 we don't have to support anymore. Lavinia will no doubt contradict me when she says there's a problem with 7.02, but it's not yet been rolled out to any of the large environments, as far as I know, but it is running on some of the smaller non-production ones, and I think it may be maybe even some production ones for some of the Elsevier guys. The biggest new features in 5.0, there's hundreds, literally, of smaller features, but the big ticket items really, the new ECL watch, which was a tech preview in 4.2, is now the default view. The improvements to the embedded languages that I think were briefly mentioned in the previous talk, in 5.0, you can stream data in and out when calling external languages. Sorry. The whole system's been designed to be translated, or the whole ECL watch system's been designed to be translatable into foreign languages. In particular, there was a big call for a Chinese version of it, but we generalized it, so you can plug in any language that you have someone who is willing to do the translation for you. So I think we have Hungarian, we have Portuguese, we have Spanish, we have Chinese, we have English. Are there any others? I can't remember. Irish, maybe. The improved compiler warnings, Gavin gave you quite a bit of a detail about that, but that really came into 5.0. The smart join improvements, I think he spoke about as well, and the Hadoop 2.2 support that I don't really know enough about to talk about, so I'll quickly pretend that isn't there. So a little bit more detail about the new ECL watch. As I said, it's no longer a tech preview. We've filled in enough of the holes that were in the 4.2 version to consider it prime time ready. It's a much more modern look, much more consistent user interface. The navigation around the ECL watch is much easier, and it's a solid foundation for future work. I've categorized this under the sort of operational self-sufficiency banner as to why we're doing it. It's ease of use. It's all about ease of use and being able to present to the user much better information about what's going on in their jobs and in the platform. I've been using the 5.0 new look ECL watch for quite a while now, and on the rare occasions when I have to go back to a 4.2 system to test out a bug, and the old ECL watch comes up, I get a sudden horrible, ugly. So it's once you're used to it, you won't want to go back. The new embedded language. There's two new languages you can embed, SQLite and MySQL. I wouldn't really recommend anybody actually embedded SQLite. I did that more of a proof of concept than anything else. It was the easiest SQL-like language for me to install on my computer when I was implementing this. But MySQL is definitely potentially a very enabling technology. I think the ability to really have a Roxy query, for example, which combines data from your indexes that you built on Thor with much more up-to-date data that's been built on MySQL, is something we actually do quite often. We've had to jump through a few hoops to do it in the past by writing a service on ESP and making SOAP calls to it to get the MySQL data. But now you can just say embed MySQL and then put a select statement inline in your ECL code, complete with parameters, datasets streamed in and out, etc. I guess part of the motivation for adding the streaming data support was that embedding MySQL didn't make a lot of sense if the only things you could pass to it were scalars or get back from it were scalars. But it's been useful for the other languages as well, and all the other languages also now support streaming datasets in and out, as well as passing simple scalars as they do in 4.2. I've got a breakout session later today, which gives much more detail on this for people who want to know more about it. Those are the big ticket items in 5.0. 5.2 is what we're really working on at the moment. Everything that we're checking in that isn't a bug fix is something that will see the light of day in 5.2. Probably, due late 2014. I suspect we'll probably create the first release candidate in 2014, but I doubt it'll go gold before early 2015, just because of the nature of all the holidays between now and then. And what's in it? More embedded languages, particularly Cassandra. I've put a Cassandra embed plugin in, mainly so that I can experiment with Cassandra as a replacement for DALI. But since I was working with it anyway, I thought I'll turn it into an ECL plugin so that anyone else who wants to store data in Cassandra or get it out of Cassandra can do so. Full JSON support. We've got partial JSON support. We've been adding it gradually over the last few versions, but it should be pretty much complete by the time 5.2 ships. Improved error reporting. That's again part of the ease of use. Gavin was saying how the compiler messages aren't great. Well, we're going to spend some time making them better. Gavin covered the optimizations really. The other items more or less speak for themselves, hopefully. And they were all, 5.2, don't take this list as gospel. Some of these might not make it. We haven't completed all of these yet, but this is sort of where we're aiming for 5.2. I've thrown in a couple of slides about the Ganglia and Nagios. Those of you who missed Gleb's presentation at lunchtime the other day, I put these in for Gleb just to because he thought he was not going to get them covered at all. Basically, Ganglia allows you to see time series data, if you like, much more easily. Things like how did the CPU usage vary over time, but also user-defined metrics like how many Roxy seeks were there over time. We've got plugins that gather that information from the HPCC cluster, store it in a Ganglia database, a Ganglia round-robin database, and then we've integrated the display of those charts that Ganglia produces into the ECL watch. This will be a tech preview in 5.2 and probably more complete in 6.0. Nagios is a similar sort of thing, but more geared towards the alerting rather than the, I think Nagios tells you preemptively something's going wrong, and Ganglia is more for, looking at, hey, what happened 5 minutes ago? Bizarre stuff was going on. Can what correlated with what? And one of the things we've had to do to get those in is make it easier to plug new capability into ECL Watch. So, these are designed in such a way that you can take the plugin code, drop it into the HPCC platform, and suddenly a new tab has appeared on ECL Watch. So, that's a technology we'll probably use for some other things in the future as well. So that's the sort of thing you'll get out of Ganglia, and that's the sort of thing you'll get out of Nagios. And any questions about those, ask Gleb rather than me. And then beyond 5.2 in 6.0, sometime in 2015 is when I expect we'll be releasing something that we'll call 6.0. And at that point, I'd like to be able to say, oh, we don't support 4.0 anymore. So that's a warning for you ops guys. Please deploy 5.0 sometime. Very provisional 6.0 features. We'd like to move the work units out of Dali and into probably Cassandra. We'd like to have 64-bit ARM support. We'd like to have some Thor multi-slave improvements. The main thing we're looking at doing there, at the moment we run multiple Thor slaves on a box as a way of helping Thor to use all of the CPUs on a box, but they run as separate processes. We'd prefer to actually fold all of those processes into a single process that, it still runs as multiple slaves as far as the partitioning of the data is concerned, but they live in the same process space. That would have quite a few advantages in terms of being able to cooperate better on how the resources are used and the memory is used. It would also mean there's some things like when you do a lookup join, for example, you send a copy of the right-hand side data to every slave, which means if you've got 6 slaves on a node, you've sent it 6 times and it's using 6 copies in memory. Well, you wouldn't need to do that if we've folded them into a single process. So there's quite a few things that, just moving them into a single process doesn't buy us anything by itself, but it enables us to do quite a lot of other improvements on the way. The improved statistics, Gavin gave you a good summary of the rationale for that, and certainly that's something you may see a tech preview of that in 5.2, but the full sort of fruits of that are more likely to appear in 6.0. And the prefix join and the sort improvements, Gavin mentioned that as well, but the sort of time frame where we're likely to be able to fix that is 6.0. If we do refactor the sort in order to be able to use it for the prefix join improvement, as Gavin was describing, there's also quite a few other things we might be able to do with it. We might be able to do a much more efficient top-N implementation. We might be able to do a very efficient percentile implementation. There's quite a few things you can do if you separate out the notion of creating your partition information from using it to do the sort, or the first part of the sort. If you make that partition information something that can be persisted and used for a subsequent sort, for example, you can make your, if you're repeatedly sorting very similar data that has the same sort of characteristics, then you can reuse the partition information for doing the sort, and various other things it enables. Beyond 6.0, see slide 4. I assume everyone remembered slide 4. Slide 4 was the, it was the strategic focus areas. I mean, we will basically be continuing to use this sort of list as our you know, checklist of you know, what we need to be doing on the platform and you know, the areas that we're going to be focusing on. And that's all I have. So questions? Oh, I forgot to mention, if you do actually want to see any of these features in 6.0, you've got to vote for our video.
Hey, Richard. Richard, on the adding this Thor slaves into one unit, how's that going to affect us in operations when we have the Thor queues being, you know, locked up by a process and then having to restart and stop those?
It should be pretty transparent to operations. I mean, at the moment, you know, the process which stops a particular Thor and doesn't stop any of the other Thors, you know, has to stop 6 processes but leave behind the other ones if you've got multiple Thors on a node. This is only rolling up the slaves within a single Thor. It's not rolling up the slaves that are on separate Thors, if that makes sense. At the moment, you can, I mean, at the moment, if you're stopping a single Thor, then you'll actually have to stop 6 slave processes and 1 master process. But there may be other Thors on the node that you don't want to stop, yeah? With this change, that will continue to be exactly the same thing, except replace the number 6 with 1.
So,
Hey, Gavin, this is regarding the compiler warnings. The depth of the warnings you can get from the compiler, is that going to be configurable in ECL server or while you're actually doing in your IDE?
in ECL server, you can configure how each individual warning can be mapped to ignore or report it as a warning or report it as an error. Or in fact, report it as an error and don't allow the ECL programmer to change it back to something else. And you can also do that for the different categories as well. Is that what you were asking?
No, you mentioned as one of the new things is categorizing all the warnings.
Yeah.
So is that category and the depth up to which you can get the warnings is going to be on the ECL server across the board for everyone, or can individual users customize it?
Well, you set the default in ECL server configuration, but you can override it per work unit.
Yeah, and we've categorized each of the warnings. So we've said, okay, this is an example of something that is almost certainly a mistake, or this is an example where it's probably a syntax error, but it is actually legal. Or so we've done that categorization. You can't change that yourself.
Any other questions?
Nope. Okay, thank you.
Yep.
Sure, get those votes. Thanks, Gavin and Richard. All right, so the platform continues to get better. Richard and team are always working on enhancements and the next best thing. So I guess 5.2 is next, and then 6.0 next year, and more to come.